Good evening and welcome back to another lecture of cloud computing. So in today's class, we are going to start our discussion about Amazon DynamoDB, which is the non-relational database service that is offered by Amazon, right? So we were mostly discussing about database services within the AWS platform. And in the last lecture, we had talked about the relational database services, essentially what are the advantages of kind of opting into the database service versus kind of like installing the database stack on our own on a compute engine, and what are the different architectures of the database services that we can set up within the AWS platform in the form of having some scaling up options, scaling out options, architectures with respect to database disaster recovery, which is in the form of multi-availability zone database deployment. So we talked about all of those features. We looked into how to create those architectures, and we had a self-exercise, which was to basically connect the RTS service that we will basically set up with respect to a full stack web server that is developed using WordPress, right? It's PHP-based content management system that we can set up and connect with our relational database services, right? So the other end of the spectrum when it comes to database services is the non-relational aspect of it, right? So essentially, if you recall the concepts of database schemas, right? So we have the relational database schema, which is built on the concept of relational algebra, as well as creating tables. And then you have different keys like primary key and foreign key that helps you establish the connectivity of the data flow between these different tables that you create within your database environment, right? In contrast to that, when we look into non-relational database schemas, or otherwise sometimes also called as NoSQL schemas, okay, not only SQL, then we have different options with respect to how we can implement the database service, right? So essentially, when you are thinking in terms of non-relational schema, you can think in terms of document-based databases, okay? You can think in terms of big tables or columnar databases. You can think in terms of key value pairs. So those are some of the well-known options that are there with respect to non-relational database service, right? So DynamoDB is amongst one of those type of schema-less database service, which implements its conceptual fundamentals using key value pair, right? And that is what DynamoDB offers us, is basically a key value storage system wherein you can input any type of data that you want as long as you have some sort of identifiable key. And the value is basically going to be the data that you store, which can be of any particular format. It doesn't have to kind of abide by the stricter requirements that you have within the relational model, okay? So the way it works, as we discussed, that it is a key value store, right? And this is developed by Amazon itself. So on the free tier account that we are essentially using, we get up to 25 gigs of storage of data within the database service. And we can run up to 200 millions of read-write requests per month for up to 12 months on the free tier account itself, right? And then it kind of reverts back to the original cost model that it has for its database, okay? So along with DynamoDB, you get the option for a NoSQL workbench, similar to workbenches that you have for relational database. So if you have ever used MySQL databases, you know for a fact that there is a MySQL workbench, which gives you kind of like a canvas to draw out your schema. It gives you a query editor and those kind of things, right? So that is also available here when you use DynamoDB. We saw that when we were using RDS, there is also an example, or there is also a availability of a workbench where you can write your queries and stuff like that for relational databases as well. So you get the same support for your non-relational database environment as well, right? We create what is known as global tables. There is no concept of creating a database per se. So what I mean by that is that if you're working with MySQL, if you're working with, let's say, Microsoft SQL Server, IBM DB2, or any of those kind of relational database engines that we are familiar with, essentially the process is that we create a database, and Okay. And then within the database, we create multiple tables, which kind of stores data from different contexts that is associated or relevant to the application logic that you're trying to support allow with the use of the database itself, right? So here, there is no concept of building a database itself. What we do is we start off with just tables, right? And the tables have rows, and the rows have the input for the data entries, right? And each table, the main structure of each of those tables is basically to have a key and then to have a value that is associated with the key. So anytime you want to access those values, you can simply just query using the key, and then it will return you the values that is associated with the key, right? So that is why we say that we get a global table rather than a database itself, right? It also gives us the option of performing encryption on the data. So if you want to kind of provide additional layer of security on the data that you're storing within these tables, within these global tables, then you can choose the option of encrypting it. So this is the option where it says encryption at rest, as we had talked about initially during the first few weeks of our classes, that when it comes to securing the data itself, you have the option for encryption at rest to kind of secure data at rest. And then when data is in transit, then you are essentially looking into security methods that will secure data in transit, right? So you have encryption at rest here. You have recovery options where you can create like check marks or checklists, the area where you want to create a recoverable copy of your tables, right? So that is a point in time recovery. And then depending on the capacity of your database that you need from the service, it can also scale up. So at certain point of time, if it sees that you're reaching a maximum capacity, then it will keep on giving you more space so that you can keep on adding more stuff. And then it also has the query language support, which is the party query language, essentially, which kind of is relevant to how you are partitioning the table, which brings you the advantages of kind of extracting different subsets of data that can be similar in nature, so to speak, right? Because you don't have separations of data based on context and it being stored in different tables. You have this one huge big table. So essentially, the way you can cluster the data is by selecting a type of key that is similar across all those data points, and then all those data points which has those similar keys can be grouped together. So that is how you kind of partition the table and make the management of your data a little bit more efficient, right? How you deal with the data and manage the data. And then any of these data which are essentially stored within DynamoDB, it can be exported, analyzed within different AWS applications. So you can store a snapshot of the database and you can store it within Amazon S3, which basically is the default go-to place for kind of keeping any of your data that is there. And then there are other applications such as IoT-based applications in the form of Amazon Kinesis. So if you have streams of data that you're capturing within your DynamoDB table coming from different sensory devices, and that needs to be sent through different data analysis processes, which you are developing using Amazon Kinesis, then you can essentially connect your DynamoDB with Kinesis and then monitor what is happening with the DB using Amazon CloudWatch. And these different types of applications can be set up when you're working with Amazon DynamoDB. Okay, so there are different use cases that are specified by AWS itself as to like what are the different instances that you can do or what you can do with DynamoDB itself. So of course, you have the basic ones, which is to develop software applications. You can connect NoSQL databases, just like you can connect relational databases. You can use DynamoDB to create what is known as media metadata stores, right? So any kind of, let's say, if you have a organization which is responsible for, let's say, streaming movies and TV shows or streaming music, right? And you need to store the metadata or the tags of each of these movies, right? Like who are the actors, actresses, who's the director, how long is the length of the movie, what is the genre, what are the ratings and stuff like that. So these are all metadata information. So if you want to create a metadata store for your media services, then essentially DynamoDB can also, DynamoDB essentially can provide you its services in order to set that up. Any kind of retail experiences. So if you want to store the information about your customers, right? So if you have a retail service with respect to, let's say, an e-commerce website, right? Or an e-commerce store, you have something along those lines. Or if you have a retail store, like a cloth store, you're selling products and stuff like that, and you need to store information about your customers, and then you need to perform some sort of market analysis on those customer information and stuff like that, right? So the place to store those customer information would be within a DynamoDB, essentially, right? And then you can also use it for different types of gaming platforms as well. So if you are working for an organization which are essentially developing gaming applications and stuff like that, right? So you can think in terms of League of Legends or Dota 2, if you're familiar with those multiplayer gaming platforms, right? Or games, essentially. Then the information about what has happened in every multiplayer gaming session, the scores, and all those associated information that you have about the players, right, and how they perform. That's a lot of data, right? So that can essentially be plugged into DynamoDB, and you can use the tables to store that information, okay? So there are companies, mainstream companies that you might be familiar with which are already using DynamoDB. Some of the popular examples are in the form of Disney is there, Dropbox has used it, Snapchat has used it, and then Zoom has also used it to kind of store the information about their participants when they were scaling up by a lot during the pandemic scenario in order to reduce their latency and stuff like that, and to be able to efficiently manage the data that was being generated at that point of time. Essentially, they took the help of DynamoDB as well, right? So you can visit the documentation of DynamoDB on AWS if you would like to learn specifically about how these different companies or what are the different use cases in a little bit more detail. If you want to read about that, then it's a good read. Then you can choose to visit the documentation on AWS with respect to DynamoDB, okay? So again, as I mentioned earlier, you don't create databases within DynamoDB. Please keep this in mind. This is a little bit different from working with relational databases, where if you remember, we gave the database an identifier, we had a username and password for the root user, but then we provided the name of the database that we wanted to create. And within that, we would have created tables once it was connected to any kind of application scenario, right? But here, we don't create any databases per se. What we create is directly table. So we just start off with the tables itself, and we start entering records to those tables, okay? The scaling is basically horizontal. If you remember, there were two types of scaling. There could be vertical scaling, which is to increase the specification and the resources of the compute engine that is hosting your database. That is what we had in relational databases. Here, there is no concept of scaling up. There is more, the concept that is there in terms of scaling is with respect to scaling out, which is horizontal scaling. So that scaling, you can either allow AWS to manage by itself, or you can specify certain parameters that will say that, okay, when you cross this many amount of records in a particular table, then add another table which will keep on receiving the new set of records that will be punched into that particular table, right? So that is the idea of scalability that is present or that is offered within DynamoDB, okay? And one of the major benefits here when it comes to scaling is that the scaling is said to be seamless. So there is no downtime when you are scaling out, okay, within this particular environment. So we saw that when we created a read replica in RDS, our actual database kind of went through a reboot process because a snapshot was created of the current state of the database. And then using that, a replica was created, right? A read replica was created. There was also some downtime when we were creating the multi-availability zone deployment architecture, when our database was used to create the standby node, right? So every time some sort of maintenance, some sort of actions that is within the domain of availability and durability of your database service was performed within the relational databases, there was a downtime that was involved for the master node itself, right? Here, there is no downtime because there is no concept of a database service. It's just tables, right? So the table kind of remains as such, and you just keep adding more tables to it, right? So it's like creating a copy of an Excel sheet, so to speak. It's not exactly practically, or it's not as simple as that, but you can think of it in terms of just creating a copy of an Excel sheet. and just making multiple copies of that, right? So that doesn't mean that the service to the Excel sheet as such, it goes down. It still remains, or it still remains in service, right? So that is a very big bonus when working with NoSQL database services like DynamoDB, is that there is no downtime per se, right? And when the replication process takes place, it by default kind of follows the disaster recovery architecture that we had for relational databases, which is to follow the multiple availability zone deployment. But all of the services are kind of consolidated within a given region, right? So in terms of architecture, these are some of the points that you have to keep in mind when you're working with a service like DynamoDB, right? And then each entry or each record or each row of a table is called an item within DynamoDB, right? It's technically called an item, but interchangeably people call it different names, right? As long as there is an understanding that this is what you're referring to. So if somebody tells you an item in a DynamoDB, well, what they're referring to is basically a data entry or a data row in that given table, right? But if you're using relational terms, then that will basically be called a record or something like that, right? And there is attributes that are associated to each item. So you can have multiple attributes that are associated to each item. But no, since that it's not a tabular structure per se, like similar to a relational table, all the attributes are not the columns, right? So you just have a key and you just have a value. So if you have more values for a given key, they will be inserted as multiple items within the particular table. So that is a major distinction with respect to the architecture of how the database is set up, is that let's say if you have a student, let's say student 1, right? And the student has a Grizzly ID, the student has a name, the student has a GPA, the student has an address. So let's say these 4 attributes are present for a student, right? So if you have relational table, then each record or each row of that table will relate to a particular student entry, and then you will have 4 columns, which will be the attribute of that particular entry, right? But in contrast to that, here, when you're working within the NoSQL environment, each entry of a table will correspond to a particular attribute entry coming from the relational table. So that means if you have 4 attributes for a given row in a relational table, then translating that to a non-relational architecture will correspond to 4 different items. Okay, so I hope everybody understands that. If not, then we can kind of just do it here again. So what I'm saying here is, let's say you have one student record. So let's call that student 1. And this student has 4 attributes, right? So let's say they have some sort of an ID, they have some sort of a name, they have some sort of GPA, and let's say they have some sort of an address that is associated with it. So if you kind of paint this architecture within a relational environment, then you will have a table, okay? And then in that table, you will have 4 different rows. 1, 2, 3, and 4, right? So each of these rows, each of these columns will have one of the attributes that is associated with your object, right? So you will have ID, you will have name, you will have GPA, and then you will have address, okay? And then each of the records corresponds to each individual object of that particular table, right? So you will have student 1 here, you will have student 2 here, and then this will continue. But when you translate this architecture, so this is basically the relational architecture. If you translate this architecture to a non-relational environment, which has, let's say, key value storage, then essentially what you're looking into is one big table, which will have 2 different columns, right? One is for the key, one is for the value, okay? And what will happen is that each individual record from the relational table, which was represented in a single row, but had 4 different columns, instead of having that, it would end up being something along these lines. So it will be the ID of the student. So it will be something like S1 ID, and then it will have a value of name, and then it will have S1 ID, and then it will have the value of GPA, and then it will have S1 ID, and then it will have the value of address. Similar things will happen with, let's say, S2. So it will have S2 ID and the name, S2 ID, and the GPA, and then S2 ID and the address. So this is how the generic translation takes place from a relational environment, a database that you're working with in a relational environment, to translating that same table to a non-relational environment. So you see the space that is required in terms of row is basically more compared to the number of columns that we generate in the relational table. And of course, there is no stricter requirements with respect to this architecture compared to this architecture, right? This architecture is much more less strict, so to speak, right? Because it's just a key and value. So this value can be anything. There is no predefined requirements. When you define your structure of the table, you don't have to specifically say that, oh, what exactly will be the data type of the values that will be present here, right? Because here, this can be a string. This will be a number or a floating point value. This will again be an alphanumeric string, right? So it can be anything. So if I add an entry for an item which stores, let's say, some kind of video file, some kind of images, I can do that as well without having to pre-declare that this is what I will be entering, right? So that is the ease of use of working with non-relational database. Whereas if you were in the relational environment, you would have first to figure out what is going to be the structure of your table, and you would have to stick with that structure. So that means I would have to declare that this name column would be essentially string, okay? But in relational databases, we call it varchar or variable character, okay? And I will have to stick to that. So that means at any point of time, if I ever change the data type of name for any given row, it will throw me an error when I'm trying to insert the data, right? Because it kind of violates the initial declaration, okay? So here you don't have any of those problems. Here, whatever value you specify, as long as it understands that, oh, this is the data type of the value, then it can basically assume that value, and then it can continue with its operations, essentially. So that is how we say that attributes are associated to each item, right? And you can have these items. And then there are two types of keys that is present here, which kind of sets up all the query operation. So the first one that you have is what they call as the partition key, right? Which essentially is responsible for partitioning the databases into different clusters depending on similar context of data, right? So here, in this example that we saw here, the partition key would be this S1 ID, or essentially this ID key will basically be the partition, right? And it will be different for student 1, student 2, student 3, up to student n, whatever the value of n is, right? And what it does, as you can see here, that it partitions the table whenever a similar set of rows ends, okay? So in this particular example that we are dealing with, if ID is the partition key, the student ID is the partition key. So you can see that if you query just based on the partition key, it will return all the values that is associated to that partition key. So we cannot claim, if you remember, like in the relational environment, we cannot claim that the partition key functions exactly the same way as that of a primary key within the relational databases, but it does allow some unique identification to a certain degree. But instead of individually identifying each and every row, it kind of is capable of identifying clusters of rows together, right? It can do that. So for example, another example of partition key could be like you can set up a zip code as a partition key, right, for a customer's database table. So that means the zip code identifies all the customers that belongs to a particular region, and that is how the table will be partitioned, right? But this also creates another issue for us, is that since it is not returning all the time unique rows as you would expect to find in a relational environment, then there has to be some sort of an additional feature if required, or additional key if required, that can further, within this particular grouping, identify individual rows and separate them from each other, right? So that means if zip code is my partition key, then I will probably need to create some sort of a phone number to kind of individually extract all the customers that belong to a particular zip code, assuming that the phone number for every customer is going to be unique, right? So we need some sort of a optional key to create further classification or to create further distinction between the items that are returned by the querying of the partition key itself. So that is where we have the sort key, which is essentially optional. So that means if you do end up in a situation where your partition key returns unique items all the time, then you don't need a sort key. Okay, but if you do end up in a situation where the partition key can return you non-unique items or can return you a grouping of rows that needs to be further separated from each other, then what you can define or declare is essentially what they call as the sort key, which is the second part of the table's primary key. So together, essentially, that is the combination of the partition key and the sorting key makes those things a primary key, right? So it is essentially a composite primary key, if you remember the concepts of databases, that we are setting up here in order to extract unique item if the scenario is in that particular direction, okay? So all of these keys, the concept of this key, since it's a key value store, it can be thought of a hash value, right? So the key is basically a pointer to where the exact value is being stored, right? So if you have read hash maps and stuff like that, that is exactly what we are building here, right? That we are going to be using, okay? So we will move forward and then switch to our AWS console to kind of go through some of the exercises of Dynamo DB table. And it is quite straightforward as it was in the relational environment. We can work with this. Yes, question?
Yeah, it looks, and pardon me if I'm wrong, but it looks like Amazon is pushing this architecture. What's in it for them?
I don't have a straight answer for that because they have set up their own architecture for relational databases as well. They have their own architecture for Linux distributions as well. So the only thing that I can think of that would make sense is that developing the architecture in its own sense will kind of make it easier for them to offer their services rather than buying licenses from other proprietary services and then offering that as a service. So that kind of cheapens the utility, like how much they charge, because they don't have to cover the licensing fees. It is being developed in-house. And then if it has similar properties to the other licensed softwares that are out there, which is offering similar type of services, then it gives them an added benefit and added edge to kind of offer those services.
That makes sense. Thanks.
Yeah. Okay. Because every time it's the easiest way to understand why would Amazon come up with their own version is to think from an OS perspective first, because that's where we saw the first offerings, right? Where AWS had its own offerings. And then if you need to offer Windows, you need to buy the license from Microsoft, right? If you need to offer Macintosh, you need to buy the license from Apple, right? So they don't say, like as we had discussed in the cloud computing architecture, the service computing model is what services you use there, right? So from a cost efficient perspective, it is not efficient to buy a license from somewhere else and not being able to push that money onto the clients and the customers, right? So to save more on that, it's better to just create something in-house which performs just as well as those licenses. Okay, so Dynamo DB. So go to, I'm already logged in here. Again, the same ritual. Check your region, make sure you're in the correct region, make sure you're using the correct IAM profile. And then in the search bar, you can search for Dynamo DB essentially, which is the managed NoSQL database, right? So go there. And this is the entry widget that everybody will be seeing. And again, as we had discussed, if things confuse you on the main canvas, pay attention to what is happening on the left vertical menu, and you will get like an overview of all the different options that is there with respect to this particular service that we are dealing with, right? So as I said, there is no concept of a database. You start off directly with the table, right? So you don't worry about compute engines and all these things. AWS will take care of where they are running these services, right? That is an additional step that you will forego if you compare this particular database service, this NoSQL service, with respect to the RDS service, so the relational database service, where we had to specify the type of compute engine on top of which you would expect or you would like to run this particular database that you are essentially provisioning from AWS, right? Here, none of those things. You directly go to the tables. If you have created the tables and if you want to update the existing tables, then you go to update settings. You can check out the status of the items that has already been inserted in the tables. So it provides you with the UI of the tables itself. So you can see what insertions have already been made, what is the current state of the table. So that is explore items. There's a query editor that is known as the partition query language, okay, or PartyQL. So any kind of querying that you would like to do using a web browser interface on AWS console, then you can write those queries here. Or you can write those queries separately on a script and you can run it through a command line interface using the AWS command directive, right? You can create backups. Backups will be saved into S3. You can export those backups that you create to S3. So that is the option. So one thing by default, remember, any backup that you create for any service is going to go to S3, okay? That is the sole place where it will go to, okay? So just remember that. If you want to create a table from S3, if you have already from some earlier time, if you have created it, and now you want to create another new table and start reusing the table that you had backed up, then you can import from S3. Reservation of capacity is basically the dedicated provisioning of your table. So Amazon will make sure that wherever this is running, is not using multi-tenancy and stuff like that. And then you have settings options and things like that, right? So we are going to go ahead and go into the tables option. So here, since we don't have any kind of tables, so this is what we will see. And you can note here from the banners, previously we didn't have deletion protection for the DynamoDB tables, right? So now they have included that. So that is like an update that they have offered. Probably a year ago, this was not present. So if you don't remember what is deletion protection, well, basically from RDS, there was a checkbox which was about deletion protection. So if you had it checked, then you cannot run any kind of scripting commands, or you cannot manually, even through the user interface, delete any of the databases that you create. So that is a protection against accidental and maliciously intentional deletion against your database protection, right? So in a production environment, you would always want to kind of keep that turned on so that nothing disastrous happens against your table, or nobody is able to kind of delete your tables, right? So that is something that they have now introduced for DynamoDB tables as well, which is a good thing to have always, right? So go ahead, create a table. Okay, and let me walk you through the different fields that you will be encountering, which will be similar to the architecture that we just discussed, right? So the first and foremost thing is that you will have to give a table name here, right? And then only letters, numbers, underscores, hyphens, and periods can be included. And we have a maximum of 255 characters, minimum of 3 characters. So I will be just giving something like test Dynamo DB demo. Okay, something like this. You guys can give your own name. As we discussed before, we will have rows. Rows will be basically items of data. Each data item will have a key, will have a value, right? And the way the primary key is set up is basically with the help of 2 keys. The second part of that key is basically optional. But if you have a scenario like this, then you can create that partition key, right? So here, you need to enter the key's name and you need to specify what is going to be the data type that that particular key will have. This is only for the 2 identifying keys so that, you know, the table kind of understands what it is dealing with. So we have to think of a use case scenario and we have to come up with some sort of a key name that would essentially work here. So we will use that student example that we were talking about, and I will give something along the lines of a, you know, like a Grizzly ID, which is going to be a string. Okay, so here you can see that there are other options. So your partition key can be true and false. So you can think of scenarios where you would like to group different data items based on true or false values. Gender comes to mind, one of the first options. any other check mark boxes that could be there, that could be present, like graduate student, undergraduate student. So all those type of classifications can be treated as binary partitioning. You can have numbers in the form of zip code. Otherwise, you can treat zip code as string, but you have to go through a little bit of conversion and stuff like that. So these are the options, the three options that are essentially available, right? You can use any kind of sort key. If you do not want to provide sort key, that is absolutely fine because it is an optional feature. But you will have to think a little bit about the architecture of how the grouping will be done and whether the grouping will return unique values or whether the grouping will return multiple values that is associated to the same partition key, right? And the example that kind of expresses that particular feature is that if you create something like a student ID, all right, so each student ID, of course, it will return multiple rows, but those rows are associated to that student ID itself, right? So if you have a situation like this, where you have created this particular student ID, and this student ID I will have, let's say, mapping to three different data items, D1, D2, and D3, but all of these different data items are essentially attributes of student ID I, okay, item I, then that is kind of okay, because you're just getting back the information for a single data entry, right? However, if you have a situation like this one, as we were talking about, like a zip code, okay, the zip code which itself will return you multiple customers. So it will return you C1, C2, C3, because a lot of customers can be associated to a particular zip code, right? So to get to this point where you are actually extracting the data items for every customer that you have on your table, or every music entry or media entry that you have in your table, you need another level of jump. You need another jump in order to get to that data point, right? So D2 and D3. So to get to this point where you can access a customer's data entries, you need some sort of a key here as well, which will allow you to make this jump and access the actual data values. So that is basically what the sort key is there for, right? So here we don't, given the fact that we have provided a particular GID, which is going to be essentially unique for every student, there is not much of a use of a sort key per se. But just for the purpose of demo and for the sake of discussion, let us just say that we put something along the lines of first name, right? This is just for the sake of discussion. This is not, about the strictness of actual database concepts. As long as you understand why this thing is present, this is what I'm trying to get at. So try to understand the purpose of this key rather than the actual key that I'm specifying here for demo purposes, right? In an actual database class, I would never suggest you to use first name as a unique identifier for different items in your databases, right? At least for those who have taken the database class with me, you would, if you recall those discussions, then you will understand what I'm talking about. I think there was an interesting discussion about creating a composite primary key, which is not an ID, essentially, and then that it was a fun discussion there. But as long as you understand, that is again what I'm trying to get at, right? So you just need these two different keys, one to group it, and then within the individual grouping, in order to perform further differentiation, you have the sort key. Okay, so then you have two options. That is, you can use the default settings, which will allow Amazon to suggest or basically adopt the different best practices related to the creation of the tables, and it will show you what type of different options that are being used, right? So that means with respect to how much read capacity it will have, write capacity, whether or not auto scaling will be present, right? So auto scaling is the part where the scaling out is managed by Amazon itself. And then you will have the creation of indexes, and then whether you are going to apply encryption, and then who will be managing the encryption key itself, right? So if you have encryption, then the best option would be to just allow Amazon to take care of it, because if you are kind of allowing Amazon to take care of that responsibility, then your share of security responsibility kind of goes down. Because if you take the responsibility of managing the keys itself, and then your keys get compromised and your data leaks, right? Then you are responsible, because you were the one who were responsible for properly managing the encryption keys, and you failed to ensure that, right? So those are the thing. And now deletion protection is a new thing, which is currently applied to it. This was not previously present. And then the standard Dynamo table class will be created, which is again an internal architectural structure, which does not interrupt much with our functionality as a client who is just trying to use the service itself, right? So we don't want to go through the default settings, right? So we will just hit customize settings, and then it will essentially show us all of the different options that is there with respect to DynamoDB, and we will give us a chance to kind of go over it and understand all of those different costs, right? So in terms of like cost management of our workload requirements and how the data access is performed, that is where we have the table class, right? So there are two different classes. If your data is accessed quite frequently, but not that, I wouldn't say that it's not as frequent as a big data access and stuff like that. But what we are trying to get at is like, okay, you have created a table that you access from time to time, right? So a very simple example would be, let's say, any of the fast food chains. So if you create a database support for those fast food chains, which is basically logging the customer orders, what kind of order they did, and all those kind of associated information, then we're talking about that frequency, that sort of frequency, and not like a frequency from a sensor device that generates data, let's say every 10th of a second or every half a second and stuff like that. Not that frequent, but frequent enough, right? So if you have a situation like this, then the type of workload classification, then data access pattern, you will be choosing the DynamoDB standard class. The other option is for infrequent data access, okay? And it is mostly about storing the data rather than accessing the data most of the times. So if you have a situation like this, then you will be using the other option that is provided by AWS, which is the standard infrequent access. That is where IA comes from, right? So we're going to just select the DynamoDB, the general purpose pattern that we are going to be doing, right? And then this is the cost calculator. That is how much of what will be the average size of the items that you will be inserting to the tables, how many reads per second will be taking place against the table. Because remember, this is a NoSQL table. At the end of the day, you can plug this in with the next-gen platforms, computing paradigms that you have in the form of cyber physical system, or relying on IoT infrastructure, edge computing architecture. Those kind of environments can be supported by this particular table, right? Relational tables are not the best suitable entities for those kind of applications. So in that particular situation, the number of read per second and the number of write per second with read consistency and write consistency can change, right? And the consistency is basically, it's coming from the transactional consistency concepts, right? So whether you will have very strict consistency, okay, or whether you will have a model like base model, which will make it eventually consistent. So as you tighten the consistency of read consistency, that will reduce the availability of your tables for concurrent queries. And as you make it less stricter, as you lighten the strictness, which is eventual consistency, then your table will be mostly available. And then you can achieve that will be coming at a cost of the integrity of the data set, right? So there can be some differences between the replica and stuff like that. So that is what this consistency aspect is for read and for write. So anytime you go transactional, that is the most strictest option that you can go. This is basically following the ACID properties for those of you who remember, okay? So we will keep the default values here, but as long as you understand what are these different options and when you should use it, that is what is more important, right? So average item size, you can decide what is it going to be, because since there is no restriction on a predefined notion of the type of value that you're going to be inserting to each of those value column, then you have to average out the size of the data items that you are kind of dealing with, right? So this kind of blows up if you're dealing with media data, actual media data itself. And if you have some sort of textual, binary data or numerical data, then the size itself is not going to be that big. So we can just put some different values to see what happens here. So let's say if you have an average size of 4 kilobytes for each data entry, right? And let's say the number of reads per second is going to be around 50, okay? And then the number of writes per second is going to be probably like 20 or something on half of that. You can see here how much essentially it is going to cost you for using the DynamoDB for a given month. Okay, and this is essentially a lot. Okay, so if we can change that to transaction consistency, the reason why the cost goes up, because this essentially locks out the tables, right? So when you increase the strictness of how you are accessing the data or how you are writing to the data, then if the availability reduces, then Amazon has to provide different ways in which they can maintain that, right? So that means that will require more units, more reading units, read replicas, more write replicas and stuff like that, so it can manage the service, right? So in the most lightest option, lenient, I think that's the antonym of strict that I've been looking for a while. So anyways, so essentially that's the whole cost calculator that you have in the capacity calculator. That is how many read capacity units, or you can think of this as nodes that will replicate the table across, right, in order to support this. And the value that we provided here, that's a lot, right? So that is going to be 50 reads per second. You can imagine that how much that is going to be in a single day, how much you're going to generate, right? So we're going to leave the most default option that we have is we will have 1 read per second. That is still a lot. To have 1 read per second, that is a lot, by the way, if you think about it, right? But if you bring it down to its bare minimum, like the size can be changed here. I can move this to 10 KB. We can see that it kind of goes up to like $5 here. But if you're dealing with an average size of around 4 KB or 5 KB of information, you're just spending $2 a month, right? So from a production standpoint, this is acceptable cost just for the database service itself if it is providing you all of these different managed services, right? So this is what the capacity calculator can offer you to get an understanding of what you're dealing with and what you're going to be working with, right? So if you change it to infrequent access, you can see that the amount further goes down. When you scale it up to very large numbers, you will start to see the difference here. But for the very basic capacities, there is probably some difference of sense with respect to storage and stuff like that. Okay. So in terms of the read-write capacity settings, that is what is going to determine how many units of read-write nodes you are going to be using. You have on demand, which is kind of simplifying the paying options when actual read and write takes place, right? But this is also going to be uncertain because you are asking AWS to kind of perform a spot reservation, so to speak, right? That, oh, I'm going to perform a read right now. Please make sure that a read unit is available for me to carry out this operation, right? So you can do that, but the better option would be to just allow all your options to Amazon itself. That is, you are provisioning the resources itself. So this is the reason why they're giving you this capacity calculator for you to figure out what is your architecture, what is your organization's demand, and then decide whether you should go for provision or whether you should go for on demand. And personally, my suggestion would be to just make sure that you understand your application and then go for provision read-write capacity and have those rather than asking for those read-write units on demand, right? So we're going to leave this to provision. Okay. Auto scaling, you can turn it on or you can turn it off. It's kind of self-explanatory. There is nothing much to kind of explain here. It's very similar to the EC2 auto scaling concepts that we discussed. Whenever you hit the throughput capacity that you have specified previously here with respect to read and write, if this value kind of increases, or if this value kind of increases, then whatever was provisioned was not enough anymore, right? So that needs to be scaled, okay? And scaling out is what will be done, right? So if you keep this auto scaling turned on, then Amazon will take care of that. So for now, just for the demo purposes, we are going to keep it off. If you keep it on, then you can see here that you have the same set of attributes that you had seen when we were learning about auto scaling group in Elastic Compute Cloud, right? EC2, right? So that is, what is the minimum unit capacity that you need to have? What is the maximum? And what will be the target utilization of each table in terms of read and write operations that will be queried against those tables, right? So if you set it up, it just asks you for how many kind of like capacity units do you want to provision. Let's say we just want to provision something along the lines of 3. It's just a value. More values will cost you more. We saw that information here. As more is required, the cost goes up here. So we're going to set it to 3, some random value that we are using. There is no mysterious purpose behind selecting 3 over 5 and stuff like that. So we're just going to go with 3. Okay. So the same option now happens in write capacity as well. So we just turn off the auto scaling group and we set this to 3, kind of make it same just for the demo purposes. Okay. So here you get to create your indexes. Again, indexes is something that you have to remember from database itself. It kind of speeds up the process of extracting data. If an index table is present, it is always suggested that you create indexes. Primary key indexes are created by default in a relational table, but since primary keys are unique, your indexes are going to be unique indexes as well. So what you need indexes for is to create grouping of data items, right? So that the search process can be sped up by quite a good degree compared to going through the table row by row, trying to find what items it is, especially for an environment like this, where all you have is a ton of rows, right? You don't have separate tables for separate data contexts and stuff like that. You just have a bunch of rows, right? So make sure that in a production environment, you create global indexes, you create local indexes based on your understanding of the data that you are dealing with, right? So here, based on our specification, it will show us ultimately like how much it will cost us. It will cost us for 3 read capacity units, 3 write capacity units, deployed to the US East 2, okay, which is the Ohio region. It will cost us about $1.75 per month using the provisioned DynamoDB standard table class. Okay, so that is what it will be offering us. So now we can choose for encryption. Okay, so encryption, AWS managed keys, I can store it in my own account. It will go into this service that is known as key management service. So essentially, KMS is where you manage your key by yourself within your account. This is your responsibility. Even though this is an AWS service that is being provided by the platform, you manage this. This is very similar to IAM services, right? Amazon provides you those services, but you are responsible for taking care of it at the end of the day. So the one that is I kind of like it is that I will just allow DynamoDB to take care of this. So I'm just going to select owned by DynamoDB. This does not cost any additional fees. So why take the headache when you know that they can take care of that management? The whole point is to kind of delegate as much as you can on the management side to the service provider, right? So I'm just going to select this here. And this wasn't there before, but this is here now, and it is very similar to the relational database table. Please do not check this button for the demo purposes. If you do check it, you have to come back to the settings of the table and you have to uncheck this for you to be able to delete the table itself. So since we are going to destroy or purge our resources once we are done with this demo, I am not checking this, okay? But what you guys need to make a note of is this thing needs to be turned on when you are deploying it in a production environment or even in a development or testing environment as well, okay? And add some tags in the production environment as well. So once everything is done, you just hit create table, and then it will take some time, and then it will create the table itself, show all of the different attributes that we dealt with. And once the table creation is done, then we can finally kind of enter the GUI or the UI of the table itself and start creating some items, right? So, okay, so this is pretty fast, and it is going to be fast compared to RDS. You will see that things will move a little bit, not a little bit, but comparatively quite fast compared to this relational service, right? So NoSQL is also fast in that aspect as well. Now, once the table creation is done, I hope everybody is at this point itself. You can raise your hand if you're lagging behind, and we can pause for you if you would like to have that. But assuming that everybody has reached this point already, then you left click this particular table, and then that will take you into the table itself, right? So we don't need this accidental write, read, delete protection. But if you want to set it up, then you can edit the PITR option, okay? And you can provide it, okay? But I'm just going to remove it. And here, what you have to pay attention to is that at the very bottom, you have the monitoring metrics, okay, of your original canvas. So that will show you the read usage, the throttle level, the write usage, the write throttles, and all those different types of option, right? And if you notice here, the different types of operations that is associated to each individual options that you have. So that means if you're performing a write, that write option can either insert data, which is basically the put item. It can update existing data, which is update item, delete item. And then if you're performing batch insertion, then you have the batch write option, right? If you look at the read operation, then you can either read the item, you can extract the item, you can scan, which is search the entire table for a particular operation. You can query the table by providing it with specific filtering attributes that will kind of restrict the amount of results that will be returned. So that is basically querying. This is a unique extraction, by the way, and query, the way it is distinguished is that you don't know exactly how many items belong to that particular filter that you're looking for. Something like, get me a car whose VIN number, vehicle identification number, is such and such. That is a get item operation, right? But if I say, get me a car, which is 2019 Chevrolet sedan, right? So these are all the different filters. So that is a query because I don't know exactly how many items are there, which kind of belongs to that, right? And if I do something like identify all cars which are Chevy, right? So that will require me to go through the entire table, see what is going on. So I'm exactly scanning the table. So query is a subset of the scan where you provide filters and stuff like that, right? More additional filters. And if you're doing batch processing, then that is the batch get item, okay? So those are the different metrics and it will show you the different options. The item summary section gives you the status of your tables. That is how many items are currently present, what is the entire size of your table, and what is the average size of the items. This will kind of reinforce the options, not the options, but basically in the capacity calculator, when you specified how many, or what is the size going to be like and stuff like that. So if you see that that is kind of changing, then you can go back and edit the settings from there, right? So this gives you the option, right? The general information is there. The general information will show you the main two things is the partition key and the sort key that is there, okay? We don't have any kind of recovery options enabled here, but if you want to enable those recovery options, you can essentially go to your settings or change the settings from here. And then you can basically turn this on if you want to kind of activate the recovery option. Capacity mode, we already saw. The provision capacity mode that we're doing, we're not doing on demand. We don't want to go in that direction and stuff like that. We don't have stream data turned on. So if you're working with sensory applications and stuff like that, you can turn on stream data, so that data will keep on coming as a stream, right? Rather than discrete events that will happen on the graph and stuff like that. And deletion protection is also turned off and all the other things that we have, right? And this is basically the address of your table. So if you want to programmatically connect your table, so this is basically the resource name that you're dealing with, and this is what you will provide when you're trying to integrate your table with other APIs and stuff like that, if you're trying to write a program, okay? At the top, you have the sub indexes or the sub, not indexes, the sub options that is there. So that was the overview. If you would like to create an index, which is not during the process of the table creation, then you come to the indexes and you can create the indexes here. This is a separate monitoring chart, which is kind of connected to CloudWatch. Anything that is monitoring is being done through CloudWatch. Keep that in mind. These are the global tables. So that means a replica, if that is created, then that will be shown here in the global tables option. You will get to see the backups here. So if you want to set up the PITR here, if you want to create a backup here by creating a snapshot, this is where you would come to, and this is where you will back it up. You have the option of exporting your data to S3. All of this information can be done. You can connect it to Amazon Kinesis data stream. So this is basically a data analysis option of AWS platforms. And then any type of additional setting that you would like to reset. So for example, the read-write capacity, the table capacity, if you want to change any of these options, if you want to turn on auto-scaling group after the table has been created at a later point of time, then you will go to additional settings, right? So essentially here, now we will move to this action button at the very top, and you can see that there's a lot of these different options that we just talked about here already, right? In the additional settings, we are looking into like, changing the table capacity and stuff like that. So you get all those options here, but what we are interested now is this create item. Okay, so hit on create item. This will open a interface for you where you can use the form option in order to enter the values, or you can go to JSON and you can enter the value. Okay, so one thing to note is that when you're working with this AWS and stuff like that, please make sure that your JSON is good. Okay, if you're not familiar with JSON, make sure your JSON is good, because there are alternatives to JSON, but those are other markup languages. We will see that in the next lesson itself. But when you don't get those alternatives, the only option that is there is JSON itself. So whether you're writing permission policies or whether you're inserting data into a particular database, you're mostly dealing with JSON APIs. Okay, that is the choice of APIs for RESTful web APIs, right? So we use always a JSON API. So as a reminder, if you're going down this particular direction, make sure that your JSON is good. But here you get another option, that is you get a user interface in order to insert the data and stuff like that. So what you do here is basically you get the original two key items that you're working with, right? So when you want to add a new attribute, let's say you have GID, so I can give some GID. So let's say 1, 2, 3, 4. This will be treated as a string, by the way, keep that in mind. We can give a first name. So we can give something like Vic, okay? And then if you have more data entry items, so let's say we had a GPA here, right? So we would like to insert the GPA of this particular student, right? So then what we do here is we go to the top corner here, we go here, we see what are the different data types that are available for us. We see that a number matches the best for what we are working with. We enter that. Here, we need to give the name of the key. So we will say something like GPA, and then we will insert something like 3.54, something along these lines, right? If you want to remove it, you can remove it, right? And then if you want to give a phone number, we can provide the same thing. Maybe we can do a Boolean. And we can give here something like student grade, not grade, student graduate. Okay, so essentially we can either say true or we can say false, but you get the idea. Okay, so once you set this up, you can go to your JSON view and you can see like how this is being created. So you have one primary JSON item, and then you have each of these keys, and then it has a value here, and then the same thing happens here. Okay, so since this is JSON, both the key side and then anything that is there which needs to be represented as a string, except for this Boolean value, everything else will be represented as a string. So that is the difference between your plain and simple object notation versus your JSON notation, right? That the key needs to be also specified as a string. Everything will be specified as a string except for that Boolean value and stuff. Okay, so now you can hit create item. There are also many other attributes here. You can do all of these different things. You can create a list, you can create a mapping, you can have binary values of zeros and ones and those kind of things, right? You can have null items, and then you just hit create item. Okay, so once you create item, let us just go ahead and create one more item here, but we need to make sure. Now, you see the beauty of this is that the next time we come to create the item itself, we don't have to follow through with the same set of attributes that we specified here, right? So we had GPA here, we had student graduate here. What we can do is when we come to create item here, we have to make sure that these two things are present, right? So I can do something along the lines of, I don't know, dragon. Okay, so and then we can add a new attribute and we can say it will be, let's say it will be some sort of Boolean value, but this time the Boolean value will be something different. So we will say student freshman. Okay, so this will be false, and then we will have another attribute. So we will do something along the lines of, let's say, a string, and we will say student certificate, and we can say something along the lines of Java certificate, right, that they have. And then we can create this item. All right. So all of this information will be present here, but you can see here that even though I inserted the items, what you can see in this particular situation, that you have the first item which is being inserted and that is being showed to you. And then those columns are not inserted for those particular items that we inserted, right? So essentially those values are not present for this second item, and those values which was inserted for the other guy, okay, which is the two things that we inserted here, that won't be present here. But that is not going to create a problem here, because this is going to allow you to keep on inserting whatever type of values that you would want to insert, right? So now on this table itself, you have the option to kind of download your results in the form of CSV options as well, right? So that means if you want to take the current state of your table, whatever your tables are, and if you would want to export that to a CSV file and not save that as a snapshot into S3, then you can do so, but you need to make sure that you actually have something on your table, some sort of a content, and then you need to go to actions, okay? And then without selecting any particular items in the list, you can essentially download the results to CSV, okay? And if you select a particular entry, okay, and then if you go to options, then you have the options to either edit that item, you can duplicate the item and then change the values, you can delete the items, you can download the selected items to your CSV, okay? So if you want to hit edit, you can see here, all this information that we had is kind of still present, but in the UI that is not being shown because the UI is kind of replicating the behavior of the first item and the attributes that it had there. So, but this information remains. Okay, don't get worried about the fact, but this information is always going to remain. You can double check it here in the JSON implementation, which is how this table is essentially being created. You can insert whatever values that you want for each and every one of those items, okay? Technically, you won't have this much of distribution with respect to the type of attributes that will be associated for each item. If you think from a practical standpoint, again, most of the application scenarios that we will be dealing with, even for NoSQL standards, even from a NoSQL standard, it's not going to vary too much. What will vary is maybe the data type might change for the type of attribute that you are taking. And the chances of that happening is going to be very less frequent compared to, right? So mostly in actual practical scenarios, you won't be seeing much of a distribution like we created here just for discussion purposes. You won't be seeing those distributions in a practical scenario. So that is something that you have to keep in mind, right? But this gives you the option for working with all of these different words, right? So then you have the option to interact directly with your DynamoDB. So I'm going to leave that second exercise up to you using the AWS CLI if you have already done it. How many of you have installed the AWS CLI at this moment on your local computers? Just one? Okay, two. That's not a promising number, but I mean, if you want to learn how it works, please install it. Okay, that gives you the ability to directly connect with this AWS platform without being within this particular console, right? So if you want to learn how that works, then you would have to go ahead and do it, okay? But essentially, there is a way to directly connect with your DynamoDB, just like you have the AWS CLI that can be used to connect with your S3 bucket, right? Your storage bucket. So before I kind of walk you through those different steps as to what is expected of you to try out and work with it, I will first of all delete this resource, okay? Just to make sure that we are not working with it, all right? So we will select everything. We will delete the items step by step, okay? So this guy is done for. And then we can kind of go back to our DynamoDB, select it, okay? And then just hit delete here, all right? So we need to give it a confirmation. Don't want to type it, so I'll just copy this. And remember, there are certain things, there are certain secondary services that are set up when you are creating this particular database, right? So one of those side services is CloudWatch. So that means CloudWatch service is running for each and every table that you create for your DynamoDB. Be very mindful of this operation. So you're not just paying for the DynamoDB itself, but it's basically a conjunction of both CloudWatch service, which is a different service within AWS, and the DynamoDB service itself. Anytime you delete something like a database, it gives you the option to create a backup for it before deletion if you want to do that. But we don't have anything right now to create a backup for. So we will not check mark this particular block here. And then we'll just confirm it and then hit delete. Okay. So, and this database service compared to relational database service is pretty fast, but of course, relational has its own benefits. So if you just want to test things out, it is just better to kind of choose this. There are other database services which are primarily there to be database services. So like Amazon is a very big platform, right? Similarly, GCP is a very big platform. Azure is a very big platform. But if you if you find yourself in a situation where you are simply trying to find a way to create just to integrate a database service to your particular applications, right? Then this is the one that is kind of well suited. Just give me one moment. So this is the database service, which is just for databases and for NoSQL databases in particular. Okay. So I believe a lot of you have heard this name before, MongoDB. Okay. It's also a key value store. So it's similar to the architecture that we have. So if you do not want to go into a mainstream cloud provider just for getting their database services, and you have nothing in particular, you don't favor or you're not biased towards anything like that, then what you do is you go with these guys, MongoDB. They will take care of the provisioning. You don't have to worry about, should I use AWS? Should I use Azure? Should I use GCP? What should I do? No worries. Use this. They will take care of everything itself. You focus on MongoDB itself or developing your database application. So this is pretty strong as long as you know relational database, as long as you know SQL, you can quickly jump into something like a MongoDB NoSQL environment, and then you can work with it pretty easily, right? And this is a very fast service, and I've tried it out, and this is pretty good, right? So if you just want a database service, which is NoSQL in nature, think about this, okay? Think about it. I'm not suggesting that you should use that one only, right? A lot of it might be dictated by your organization as well. All right. So, okay. So the self-exercise that you are supposed to do here. So the way that we want to set it up is that instead of inserting the data one by one, essentially what we want to do is write a script that will allow us to insert the data in one full go. So that is what we want to do. So you have been given a link here. The only thing that I want to see is if this link is still operational. Otherwise, you will have to write your own code to kind of work with that, right? So let me just real quick check this out. And it's not allowing me to copy the hyperlink. That is weird. All right, this is weird. How about I do open hyperlink? Okay, so essentially what we are setting up for, at least in the example, the strategy that is written is with respect to retail management. Okay, so we have a thing that is known as a stock keeping unit identity. So if you have ever seen any kind of item that you order from, let's say, well, Amazon or Target or Walmart or something like that, and an item comes to you, you see these kind of stickers, right? If you order something from UPS, if you're couriering a package, right, from FedEx or UPS, you see all of these different barcodes, and then it has all of these different information about the stock items and stuff like that, right? So it gives you all of those different information about how you're going to manage these different retail products that you have in your inventory, right? For any organization that you're dealing with, there will be some sort of a stock management situation, right? The stock could be products, the stock could be people, depending on the logic of your application. So what this application is all about, or this exercise is all about, is that you want to first create a script, and that script has to be in JSON. So if you do not understand how to write the JSON, well, the way you need to learn it is by creating a table here using the user interface and then looking at the JSON file there in order to understand the structure of a single item entry within your database and how it needs to be written in JSON. What you need to do thereafter is basically generate an entire script file of JSON file, which will have all of these different attributes that is associated to a stock retail management operation. Okay, so that means you will have some sort of an email, when it was created, what is the product type, what is the price per quantity, how many quantity has been ordered by the client, and then what is the identification number of that particular item that has been ordered, right? So that is going to be what an entry would look like for a particular stock management operation, okay, or retail management operation. So you need to set this up using JSON, okay? So what you can do is you can write a Python script to generate a lot of data entries. This will also revise a little bit of your Python concepts. If you are rusty in Python, you can use any other language as long as you can write to a file which will be of type JSON using that same structure that JSON needs to have in order to enter into your DynamoDB, right? You save this as a JSON, okay? And then the objective of this exercise is to take that JSON file, which is typically what you will be doing when you will be working with within proper environments. You will be uploading that JSON file from some sort of a command line interface. Here we are looking into command line interface. This can be easily replaced by a programmatic access, right? An API or something of those sorts, right? So you will have to insert it into DynamoDB using the CLI, right? And then you also have the capability to run scans and query operations on that table using the command line interface. Again, the purpose of this operation goes beyond just using CLI. It is to kind of instill the confidence in you that you will be able to kind of integrate this database to any kind of API access, right? So the API that you're using in this particular exercise is the CLI API. So this is the structure of the JSON that you need to follow in order to insert batch data into your DynamoDB table. So I have given you the example for one of them, okay? And these listing of tables. All you need to do is write a script that will generate a file like this. Of course, the indentations are broken, so you need to take care of the indentations and insert it into DynamoDB, okay? So I've given you one general example. You create a file which probably has, let's say, 10 items, something like that, or 5 items if you do not want to write the script, but at least have more than 1 or 2, okay? And then once that is done, the first step that you have to do is you need to go to the interface for DynamoDB here. Once that file is ready, then you need to set up your partition key. You have to set up your sort key that you will have to specify. I leave that up to you, depending on the attributes that I have specified here, which one you would like to treat as a partition key, which one you would like to treat as a sort key. That is also a good revision exercise for databases. And then once that is ready, you need to import the data from the CLI and you need to push it onto DynamoDB. So you need to have the AWS directive, which is basically installing the AWS access for your command line interface on your local machine. Now we are not accessing S3, we're accessing DynamoDB. So we are going to use the DynamoDB. We're going to specify what operation that we are going to be performing. So we are going to be doing a batch write item. So we are pushing in batch a lot of items into our table. So that is basically the operation. Request items is basically the input source of where the items are. It will be present in the JSON file that you will create in your local directory, wherever that is present, okay, wherever you're running into it. Then you hit enter, give it some time, and then go back to this portal and check in the interface if you can see all of the insertions happening or not, okay? And then if you would like to query the table from CLI or from an API, essentially you would use AWS again, DynamoDB, but this time we are not doing a batch write item operation. We are doing a scan operation. So we will provide the table name that we have created in DynamoDB, and then we will provide the username who is performing the scan. That is you, right? So the username who is essentially performing the scan operation. So you will provide that and then execute that operation, and this will return you the entire table, okay? If you want to perform specific query operations, I'm not showing you how to do exact get item operations, but if you do get item operations, you better have a unique key. Otherwise, the get item operations will be like, oh, well, what's the point, right? But if you want to do the more generic version of querying the table, then this example here is an example where you can do individual queries. So here you can see that after DynamoDB, we specify the type of operation that we're doing, the table on which the operation that we're doing, and depending on the type of operation, you will have additional commands here. So here we have key conditions where we specify what is the client ID, okay, and that needs to be equal to the attribute value list, and so on and so forth, right? So if you have worked with MongoDB and stuff like that, you will see that the language that we are using here, the PQL language, or the party query language that essentially we are using to query the table, structurally, it is a little bit similar to how MongoDB is queried, because MongoDB also sets it up as key value pair, but the actual syntax is a little bit different, right? So if you need additional help, if you need or if you are interested in executing more queries, then please visit the documentation for CLI access, and then it will give you the directives of how you can run all those different commands, okay? So whether or not you do it, it's up to you. If you do it, you will learn it. If not, it will just remain as a fragment of your imagination. So that decision is on you, and you will get to decide what you want to do with it. Okay, so I've shown you this, so please practice it if you want to learn it. It is a useful feature to be aware of, and you might find it to be useful sometime in your career later on down the stage. If you are ever encountering a scenario where you need to integrate something like this, you will remember that, hey, I did an operation like this, maybe I can use it. Or if you're going for the certification examination after this, then this will be helpful as well. Okay, so any questions? All right, if there are none, then I would like to kind of show you the, what do you call it? I forgot. Yeah, a little bit of insight into the next topic that we have. All right. So that is to basically perform automation in AWS. All right. So we are slowly moving towards DevOps, essentially, and other services that is there. But it essentially starts off from automation. Okay. And the two main services with respect to performing automation in AWS itself is known as CloudFormation, and the second one is Elastic Beanstalk. The Elastic Beanstalk is specifically there for developing your full stack applications, your web applications, using all of the different technologies that we have. And then CloudFormation is an interesting service. And the reason why I say interesting service is now, till this point, all the infrastructure as a service that we had been working with, we were going to the Amazon UI, right? And then we were kind of accessing the user interface, and then we were creating the service, right? So for example, if you would like to launch an entire EC2 architecture, which kind of spans across the VPC that you're working in and stuff like that, you would probably have to use a auto-scaling group, right? So, and then the auto-scaling group, you have to specify the elastic load balances, the target tracking policies, and all of those different behaviors, and then set your architecture up, right? In this particular instance, right, not all the time you would have UI access, right? What happens if you would want to write a script and further automate the process rather than manually selecting the fields one by one? If you are capable of specifying the entire architecture of the infrastructure that you're trying to provision for yourself on the AWS platform as a script, as a code, then that will further make the process of provisioning more effective and efficient. Okay, so that is basically the service of CloudFormation, which talks about this idea of infrastructure as code, not infrastructure as a service, but basically it is IAC service itself, which is infrastructure and code. And the whole logic behind infrastructure as a code is to provision any kind of resources on the AWS platform. We will essentially write a script. The script could be in either JSON format or YAML format, okay? And when you load that script or when you execute that script through CloudFormation, then it will implement everything that you have written within that script, right? So it is a pretty beautiful feature. And for more advanced cloud architects, they will essentially rely on infrastructure as a code rather than sitting down, going to each of these individual portals, and then manually kind of setting up the architecture one by one, okay? So when you write those infrastructure as a code, you can save that, or you can use different templates that are already available for different service provisioning or different software stacks that are out there. So you save that in S3. The documentation is available for CloudFormation to get you started. And then once you execute it through CloudFormation, then the output essentially is the deployment or the provisioning of all the different resources that you have specified in your code itself, right? So it's a very powerful tool that is there, and a lot of people use it as well. So you can check out the use cases again from the information, okay? But you need to either know how JSON works, or you need to know how YAML works, okay? These are the two main options that we have to write the scripts for infrastructure as a code, right? So most of the templates that you will see in the documentation is going to follow either of these two different formats, okay? These formats are interchangeable. You can use it, whichever one that you like. And my suggestion to you would be to just stick to the format that you are most comfortable with, okay? YAML is a little bit more cleaner. It's a little bit more faster. But if you're already familiar with the JavaScript object notation, then you might as well go with that, right? So this is an example of a YAML doc. We will talk about that later. The only thing that I want to show you for today is, let's say, what we deploy, the resources that we deploy. We don't say that we are deploying an EC2. We don't say that we are deploying a database, RDS. We don't say we are deploying a Dynamo table. We don't say that the resources that we're deploying, we don't name the actual resources. Anything that is deployed is in the form of a stack using CloudFormation. Okay, so we might say that, oh, we are deploying a LAMP stack, right, which is the Linux Apache stack, the PHP stack, MySQL, the web service, the full stack, right? So we will say that we're deploying a stack, right? So that is what we will essentially say. So any set of resources that you deploy is essentially going to be some form of a stack. That is what they are called, right? So here we can see that we are basically deploying a single EC2 instance, right? So we are provisioning just a basic computing stack, okay, an EC2 engine stack, okay? So as you can see here, all that is there in the script are basically the fields that we saw from the interface when we were trying to deploy a single EC2 instance, right? So the whole process of going through that interface can be kind of summarized within this particular YAML script. So this is basically the syntax for YAML script. In the next class, I will go over the differences between them for those who are unfamiliar with it. And this is basically the JSON script, okay? So these are the set of fields. If you kind of make a generic breakdown of the structure of your infrastructure as a code template, then what you're providing is basically the description of what you're doing, what is going to be the metadata, okay, additional information regarding your stack that you're trying to deploy, where it will go and stuff like that, any kind of additional parameters that you will have, that is user data and stuff like that, any rules, any kind of mapping. I'll talk about each of these individually in details, conditions, transforms, and then in this here, this resource, all of these additional features are optional, right? But this resources is where you specifically provide what exactly do you want Amazon to provision for you, okay? So that is what it is going to do in terms of execution. That is, it will take these resources. Everything else is kind of like, okay, you may, if you want to, but if you don't want to, it's fine, okay? So you can take this example for instance, right? So here what we are doing is we are taking in YAML, we want to launch an EC2 instance. The name of the EC2 instance is my EC2 instance, okay? And then we are mapping it to the actual AWS resource, which is going to be created for that particular resource that you're wanting to deploy. We specify the image ID. So we are using the Amazon Linux machine image ID here. We specify the instance type as T2 micro. We have to specify the security key name, because remember, if you want to connect to this particular resource, then you need to specify what key you're using. And then any kind of volume mapping that you can see here, you will specify all of these options, okay? So this further improves the process of automation of very large resources, okay? So for example, there is a stack here. This is a canvas that is provided by the CloudFormation design tool, right? So essentially what this is representing here is a multi-availability zone LAMP stack, which essentially stands for Linux, Apache, MySQL, and PHP. It's a full stack application, which is supported by a relational database, well, since it is a LAMP stack, but it also has an application load balancer that is deployed. So if you ask yourself now, if I tell you now to set this up by yourself, try to think in your head or try to visualize that how are you going to do it based on what you already know, right? So if you do that mental exercise first, then if you do this CloudFormation operation using a script, you would be able to appreciate what CloudFormation brings to the table. So in the next class, this is what we are going to be discussing, which will be automation on AWS with the specific focus on CloudFormation. And then if time permits, then we will go into Elastic Beanstalk that will lead us towards the next domain of services that we are going to learn in terms of DevOps, continuous delivery and continuous integration, content delivery networks, and those kind of things. So we will set that up. We will set that discussion up in next Monday's class. Okay. So we will wrap up here, and I will take any questions that you may have at this point of time.